Hello children, in the last session we have seen all the concepts of planes. Now based on the concepts of the planes we have to complete the problems which is given in exercise 11.3. This is the last exercise for this chapter and the syllabus is end. Now come to the first problem. In each of the following cases, determine the direction cosines of the normal to the plane and the distance from the origin. You have to find out direction cosines and distance from the origin. So whenever it is given distance from the origin, so distance from the origin. So just we write the concept here. Distance from origin to plane is equals to d. When d is given, distance is given, then equation of plane must be of the form r dot n cap is equals to d, or it should be of the form lx plus my plus lz is equals to d. So this must be either in vector form or it must be in the Cartesian form. Now in this, all are given in Cartesian form. So let me take one or two problems and one or two problems you can do it. First one, z is equals to 2. Write in proper form, that is, which implies 0 into x plus 0 into y plus 1 into z is equals to 2. Now, this is the general equation of a plane. Whether it is in the normal form, that means everything it must be in direction cosines only. When it is to be in the direction cosines, you have to get direction cosines, not direction ratios. These are all what? They are the direction ratios. 0, 0, 1 are the direction ratios. But we have to get direction cosines. What we do? Dividing by dividing 1 by dividing 1 by under root of 0 square plus 0 square plus 1 square is nothing but 1, which implies 0 by 1 into x plus 0 by 1 into y plus 1 by 1 into z is equals to 2 by 1, which is nothing but 0 into x plus 0 into y plus 1 into z is equals to 2, which is of the form Lx plus My plus Lz is equals to d, where direction cosines are L, M, N, which is equals to 0, 0, 1, and distance, perpendicular distance from origin is equals to d is nothing but 2. So I can write directly, but I am following the same procedure whatever may be the problem. Let me see one more problem. That is, when I take C, that is given 2x plus 3y minus z is equals to 5. So that is the given equation of a plane. You have to find out direction cosines of the normal as well as the perpendicular distance. That means it must be of the form Lx plus My plus Lz is equals to d. Suppose here it is minus is there, that you have to multiply both sides by minus to make it RHS as positive, because distance cannot be negative. Now, how to do this? Dividing 1 by under root of 2 square plus 3 square minus 1 square, we get, so this is equals to, you can finish off here, is equals to 4 plus 9 plus 1 is equals to root 14. We get 2 by root 14x plus 3 by root 14y plus minus 1 by root 14z is equals to 5 by root 14. Dividing everything by root 14. Now which is of the form Lx plus My plus Nz is equals to D, where DC's or L comma M comma N, which is 2 by root 14, 3 by root 14, minus 1 by root 14, and perpendicular distance from origin is equals to D is nothing but 5 by root 14. I hope this is clear. I have given the same procedure whether it is given only one coordinate or given all the three. So I have given the same procedure. You can also follow the same procedure. I hope it is clear, children. Now let me proceed to next one. Next is second one. Find the vector equation of a plane which is at a distance of 7 units from the origin. D is given and normal to the vector 3i plus 5j minus 6k. So second one is given distance from origin to plane is equals to D is equals to 7 units, and normal vector is equals to N is equals to 3i plus 5j minus 6k. That is, normal is given. Whenever perpendicular distance is given, the equation of the plane is R dot n cap is equals to D. So when n is given, find out what is n cap. Then how do you find this? For that, find magnitude of n, which is equals to 3 square plus 5 square minus 6 whole square is nothing but 9 plus 25 plus 36, which is equals to, this is 30, 45, it is nothing but 70. Therefore, n cap is equals to n by magnitude of n, that is 1 by root 70 into 3i plus 5j minus 6k. So, the equation of a plane with the perpendicular distance from the origin is R dot n cap is equals to D, which implies R dot n cap is 1 by root 70 into 3i plus 5j minus 6k is equals to 7. So which implies R dot 3i plus 5j minus 6k, do the cross multiplication, this is 7 into root 70. I hope it is clear. Whenever perpendicular distance from the origin is given, the equation is R dot n cap is equals to D. Now let me come to the third one. Find the Cartesian equation of the following planes. You have to find out the Cartesian equation. It is very simple. How do you find the Cartesian equation? Replace R by xi plus yj plus zk. That's all, nothing else. So first one, given R dot minus k is equals to 2. Bring into Cartesian form. For that, which implies r is nothing but just write xi plus yj plus zk dot I plus j minus k is equals to 2. Do the dot product. This is x plus y minus z is equals to 2. That's all, which is nothing but the required equation of a plane in Cartesian form. So I hope it is clear, children. Just replace r by xi, yj, zk, then do the dot product, which automatically will become the equation of a Cartesian, equation of a plane in Cartesian form. Next, we'll come to fourth problem. The next one is fourth one, that is, in the following cases, find the coordinates of the foot of the perpendicular drawn from the origin. Foot of the perpendicular drawn from the origin. Suppose you take L of x1, y1, z1. Foot of the perpendicular. Foot of the perpendicular drawn from the origin. This foot of the perpendicular, you have to find out. Now, how do you find the foot of the perpendicular? Since it is the distance from the origin, when it is used the word, we go to the equation of the plane when perpendicular distance is given. That is r dot n cap is equals to d. Now, come here. Given first is, given plane is 2x plus 3y plus 4z minus 12 is equals to 0. We have to find out, foot of perpendicular drawn from origin. Then foot is this, of the perpendicular drawn from origin. So you have to find out this. Now for this, what we do is, since it is given, we go to the normal form, that is r dot n cap is equals to d. So for that, what do you do? Dividing 1 throughout by under root 2 square plus 3 square plus 4 square, which is equals to under root 4 plus 9 plus 16 is nothing but root 29. Therefore, 1 implies 2 by root 29x plus 3 by root 29y plus 4 by root 29z is equals to 12 by root 29. Therefore, this is direction cosines of OL. This is the perpendicular. For this line, direction cosines are, because this is n is a normal and n cap is a unit vector. When unit vector, direction cosines of OL are 2 by root 29, 3 by root 29, 4 by root 29. These are the direction cosines. But here, let foot of perpendicular is equals to L of x1, y1, z1. We are assuming that x1, y1, z1 are the foot of the perpendicular. Then drs of OL are, what are the drs of OL? x1 minus 0, y1 minus 0, z1 minus 0. That is x1 minus 0, y1 minus 0, z1 minus 0, which is nothing but x1, comma y1, comma z1. For the same line OL, you are having the direction cosines and you are having the direction ratios. When direction cosines and the direction ratios are there for the same line, they will be in the same proportion. We know that BC's and BR's of a line are in same proportion. That is x1 by 2 by root 29 is equals to y1 by 3 by root 29 is equals to z1 by 4 by root 29. Let you assume that is equals to k, which implies x1 is equals to 2k by root 29, y1 is equals to 3k by root 29, z1 is equals to 4k by root 29. But where are these x1, y1, z1? x1, y1, z1 are lying in the plane. But x1, y1, z1 lies in plane 1. When they are lying in the plane 1, substitute in 1 by substituting in 1. We get 2 into x1 is 2k by root 29 plus 3 into y is 3k by root 29 plus 4z, that is 4 into, when you substitute z value, this will be 4k by root 29 minus 12 is equals to 0, which implies 4k by root 29 plus 9k by root 29 plus 16k by root 29 is equals to 12, which implies, now this is 16 plus 4, 20 plus 9, 29k by root 29 is equals to 12. So, which implies k is equals to 12 into root 29 by root 29. K is equals to 12 into root 29 by 29. This is nothing but 12 by root 29. So we have got what is the value of k. Now just you substitute here. Therefore, foot of perpendicular is equals to x1, y1, z1, which is equals to 2 by root 29 into k value is 12 by root 29, y1 value is 3 by root 29, k value is 12 by root 29, z1 is 4 by root 29 into k is 12 by root 29, which is equals to 24 by 29, 36 by 29, 48 by 29, which are the coordinates of foot of the perpendicular. Though it is lengthy, concept is very small. What is that? Find the direction cosines by using the formula and find the direction ratios by assuming the foot of the perpendicular. Direction ratios and direction cosines are in the same proportion. From that, find what is x1, y1, z1. This x1, y1, z1 are lying in the same plane. Therefore, substitute in the equation of the plane and find the value of k. After finding k value, you just substitute in x1, y1, z1. We will get foot of the perpendicular. Once you practice, it will become easier. Next problem is find the vector and Cartesian equation of the planes passing through 1, 0, -2 and normal to the plane is. So, fifth one, given plane passing through 1, 0, -2 whose position vector is A is equals to, right from that, when it is passing through a point, you have to find the position vector also. Is nothing but A is equals to I plus 0j minus 2k and normal to the plane, and normal vector is n is equals to, it is given as I plus j minus k whose direction ratios are 1, 1, These are the direction ratios of the normal. So you can take it as A, B, C. In vector form, the equation of plane is R dot n is equals to A dot n, or R minus A dot n is equals to 0. So is R dot n is equals to A dot n, which implies R dot n is nothing but I plus j minus k is equals to A is I plus 0j minus 2k dot n is I plus j minus k. So which implies R dot I plus j minus k is equals to 1 into 1 is 1, 0 into anything is 0, minus 2 into minus 1 is plus 2. So which implies R dot I plus j minus k is equals to 3. So which is the equation of a plane in vector form. Then what is the Cartesian form? Cartesian form is equation of a plane is, can you recall? A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0. Which is x1, y1, z1? x1, y1, z1. These are all a, b, c. Just to substitute in the formula, that's all. That is 1 into x minus 1 plus 1 into y minus 0 plus c is minus 1 into z minus of z1, that is z minus of minus z plus 2 is equals to 0, which implies x minus 1 plus y minus z minus 2 is equals to 0. This is x plus y minus z minus 3 is equals to 0, or x plus y minus z is equals to 3. When you see both, it will be the same. When I put x is like r is xi plus yz plus zk, this will be x plus y minus z is equals to 3. There also we are getting the same thing only. So there is no difference. From here you can find the Cartesian form directly by substituting xi plus yz plus zk also. You can do in that, or directly you can apply the formula. Whichever way is convenient for you, you can go for that method. Next is find the equation of the plane passing through 3 points. So sixth one is given points are (1, 1 comma minus 1, 6 comma 4 comma minus 5, and minus 4, minus 2, 3. So the plane passing through 3 points, x1, y1, z1, x2, y2, z2, x3, y3, z3. So nothing is given vector form or Cartesian form, you need not to worry at all. So directly you can write the Cartesian form. So equation of a plane passing through 3 points is determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equals to 0. Just to substitute the values, this is x minus 1, y minus 1, z plus 1. Then 6 minus 1, 4 minus 1, minus 5 plus 1. Next, minus 4 minus 1, minus 2 minus 1, 3 plus 1 is equals to 0. Which implies x minus 1, y minus 1, z plus 1, 6 minus 1, 5, 4 minus 1, 3, minus 5 plus 1, minus 4, minus 4 minus 1, minus 5, minus 3, 3 plus 1, 4 is equals to 0. Which implies x minus 1 into, by leaving the corresponding row, corresponding column, 12 minus 12 minus of y minus 1 into, by leaving the corresponding row, corresponding column, 20 minus 20 plus z plus 1 into, by leaving the corresponding row, corresponding column, minus 15 plus 15 is equal to 0, which implies 0 is equals to 0. That means plane is not possible with these 3 points. The reason is all these 3 points are lying on the same line. But procedure, same procedure. So plane does not exist. Plane does not exist with these 3 points. With these 3 points. So because there is no x, no y, no z, everything becoming 0, plane does not exist with these 3 points. Behind this, the reason is all these 3 points are lying on the same line. Because whenever plane is uniquely determined, these 3 points must be non-collinear. When non-collinear only, plane will be determined. But here it is not determined, means those 3 points are lying on the same line. I hope it is clear. The next one is find the intercepts cut off by the plane 2x plus y minus z is equals to 5. So given plane is 2x plus y minus z is equals to 5. What is the intercept form? It should be of the form x by a plus y by b plus z by c is equals to 1. So dividing this by 5, dividing throughout by 5, 2 by 5x plus y by 5 minus z by 5 is equals to 5 by 5, which implies x by 5 by 2 plus y by 5 plus z by minus 5 is equals to 1, which is of the form x by a plus y by b plus z by c is equals to 1. Therefore, x intercept is equals to 5 by 2. Y-intercept is equals to 5 and Z-intercept is equals to minus 5. Next. Eighth one. Find the equation of the plane with intercept 3 on the y-axis and parallel to ZOX plane. See, this is z-axis and this is x-axis. So, this is ZOX plane. That wall is nothing but ZOX plane. Parallel to ZOX plane. Parallel to ZOX plane at a distance of y is equals to 3 units. See, a line parallel to, plane parallel to ZOX is nothing but y is equals to k. First here we have seen a plane parallel to ZOX plane is nothing but y is equals to constant. That constant is given 3 units. Therefore, the equation of a plane parallel to ZOX plane at a distance of 3 units is nothing but y is equals to 3. This is a simple oral question. So, the plane parallel to ZOX plane and at a distance of 3 units on y-axis is y is equals to 3. That's all, nothing else, nothing to say, nothing to prove. The parallel to ZOX plane is nothing but y is equals to k. Distance is already given, therefore y is equals to 3 is the direct oral answer. This is. Next, come to ninth problem. Ninth one, it is given that find the equation of the plane through the intersection of two planes and through the point. So, ninth one, 10th one, 11th one, it is one and the same only, there will not be any change. Find the equation of a line, find the equation of a line passing through the intersection of two planes. So, let me start with ninth one. Given planes are 3x minus y plus 2z minus 4 is equals to 0 and x plus y plus z minus 2 is equals to 0, named as 1 and named as 2. The equation of a plane, passing through intersection of planes 1 and 2 is passing through the intersection of the planes is adding these two planes by using the scalar multiple, that is 1 plus lambda 2 is equals to 0. That's all only. Is 3x minus y plus 2z minus 4 plus lambda times of x plus y plus z minus 2 is equals to 0. That's all, just combining. Even if it is in the vector form, r dot n1 is equals to d, r dot n2 is equals to d2, r dot n1 is equals to d1. Even the vector form I am telling. R dot n1 is equals to d1, and if it is r dot n2 is equals to d2, then the plane passing through the intersection of two planes will be r dot n1 plus lambda times of n2 is equals to d1 plus lambda times of d2. So as it is, you have to write it. After this, condition will be changed. What will be the conditions? It is passing through the point. When it is passing through the point, replace x, y, z by the given point. If it is perpendicular to another line, what you have to do? consider the drs. What will be the drs of this plane? This is 3x, here it is lambda x. So 3 plus lambda will be the dr. Minus y plus lambda y. So minus 1 plus lambda will be the dr. 2 plus lambda will be the dr of z. So you can find the drs when they are perpendicular, dot product will be equals to 0. So I hope you are understanding. You are writing the equation of a plane. After this, conditions will be changed. It will not be given only passing through the point. They may give that the z-intercept of z will be 0 or passing through the point or it is perpendicular. Let it be given any condition. Why should we bother? Whatever is given, accordingly we have to complete off. Now what is given? Also given that 3 passes through. Also given that 3 passes through the point 2, 1. 2, 1. Just to substitute it, this is 3 into 2 minus 2 plus 2 into 1 minus 4 plus lambda times of 2 plus 2 plus 1 minus 2 is equals to 0. Now this is minus 2 plus 2 gets cancelled, 6 minus 4 is 2, 2 minus 2 gets cancelled, plus lambda 3 is equals to 0, which implies lambda is equals to minus 2 by 3. Why we are giving all this condition? Just to find what is the value of lambda. By substituting lambda is equals to minus 2 by 3. In 3 we get 3x minus y plus 2z minus 4 minus 2 by 3 into this is x plus y plus z minus 2 is equals to 0. Take the LCM. This is 9x minus 3y plus 6z minus 12 minus 2x minus 2y minus 2z plus 4 is equals to 0, which implies 9x minus 2x, 7x minus 3y minus 2y minus 5y, 6z minus 2z minus 4z minus 12 plus 4 minus 8 is equals to 0. So whatever may be the problem passing through the intersection means you have to follow the same. After this, conditions may be changed. So the conditions already we know, whatever condition may be given, whether it is perpendicular or parallel, whatever is given, we know the conditions. Directly you can finish off. The next one is find the angle between the planes. Find the angle between the planes. So given planes are r dot 2i plus 2j minus 3k is equals to 5. From this, n1 is equals to 2i plus 2j minus 3k, and another plane r dot 3i minus 3j plus 5k is equals to 3, which implies n2 is equals to 3i minus 3j plus 5k. Why I am writing this? Which is of the form r dot n1 is equals to d, r dot n2 is equals to d, which are of those forms. From that, what is n1, what is n2, just I have traced it. Now you have to find out the angle between the two planes. So angle between two planes is cos theta is equals to n1 dot n2 by magnitude of n1 into magnitude of n2. So this is 2i plus 2j minus 3k dot 3i minus 3j plus 5k by under root 2 square plus 2 square minus 3 square into 3 square plus minus 3 square plus 5 square, which is equals to 2 3s are 6 minus 6 minus 15 by under root 4 plus 4 8 plus 9 17, and this is 9 plus 9 18 plus 25. So 25 18, this will be 43. So which is equals to 15 by root 17 into root 43. That is cos theta value. Therefore theta is equals to cos inverse of 15 by root 17 into root 43. That is how to find the angle between them. Next, in the following cases, determine whether the given planes are parallel or perpendicular, or in case of neither, you have to find the angle between them. How do you check? Parallel. A1 by A2 is equals to B1 by B2 is equals to C1 by C2. Then they are parallel. A1 into A2 plus B1 into B2 plus C1 into C2 is equals to 0. They are perpendicular. Otherwise, you have to find the angle between them. So 13th, A. Given planes are 7x plus 5y plus 6z plus 30 is equals to 0, and 3x minus y minus 10z plus 4 is equals to 0. In this, A1, B1, C1, A2, B2, C. To check parallelism, what you have to do? If they are parallel, you have to stop there. If they are perpendicular, you have to stop there. If not, then only you have to go for the angle. So parallelism, first one, A1 by A2 is equals to 7 by 3, comma, B1 by B2 is equals to 5 by minus 1. So A1 by A2 is not equals to B1 by B2, which implies planes are not parallel. Planes are not parallel. Then you have to check whether they are perpendicular. So perpendicularity, you have to check for perpendicularity. That is A1 A2 plus B1 B2 plus C1 C2. So multiply A7 into 3 plus 5 into minus 1 plus 6 into minus 10. This is 7 3s are 21 minus 5 minus 60, which is not equals to 0. Am I right? 21 minus 65, which is not equals to 0. Therefore, these two planes are not perpendicular. Therefore, planes are not perpendicular. If they are perpendicular, we will stop here only. Since they are not perpendicular, then we are going for the angle. That is, cos theta is equals to A1 A2 plus B1 B2 plus C1 C2 by under root A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. So this value you can find it out. Minus 65 plus 21 is equals to minus, this is 65, 21, 44. So you can write directly, no need of finding once again. So this will be minus 41. Minus 41 by under root of, so that is 7 square plus 5 square plus 6 square into under root 3 square plus minus 1 square plus minus 10 square. Same thing, whatever we have done here, same thing you are doing there also. So the calculations I am not doing, you complete the calculation. So I hope this is clear. Whereas in 12th one, only finding the angle. In 13th one, you are checking whether they are parallel. Stop if they are parallel. If not, go for the perpendicular. If they are perpendicular, stop it. If they are not perpendicular, then go for the angle between the planes. So I hope this is clear. Now we go to the last problem. Now the last problem of this chapter is you have to find out the perpendicular distance from any point, not only from the origin. From the origin, that is different. Now from any point to the plane, perpendicular distance from any point to the plane. For that, what formula I have given? Just to substitute the point, that's more than enough. Then perpendicular distance from 3, minus 2, 1 to plane 1 is, so you assume this is 1. Plane 1 is, just substitute 3, minus 2, 1 in the given plane. That is 2 into 3 minus of minus 2 plus 2 into 1 plus 3 by under root of sum of the squares of drs of normal, that is 2 square plus minus 1 square plus 2 square. What is the drs? 2 minus 1, 2, which is equals to 6 plus 2 plus 2 plus 3 by under root 4 plus 4, 8 plus 1, 9, which is equals to 13 by 3 units. So it is nothing but the perpendicular distance from, not only from the origin, from any point. If origin is coming also, just you can put in the same way. So I hope I have cleared every concept and I have done all the models of the problems. So with this we wind up three-dimensional geometry. Thank you.